Okay, so the site we are working on is the site called Selhausen. It's an agricultural rural area in the western part of Germany, and the topography is very flat. So we have slopes of maximum 4 degrees, and it's an heterogeneous soil structure. So normally we have fluvial deposits, but we have locally very different portions of gravel. And main crops on the sites are sugar beet, winter wheat, and winter barley. So at the case study site, we have about 50 plots of agricultural activities, and we are testing physical-based modeling on this plot scale. So the idea here is to simulate the water cycle, the energy cycle, and the nitrogen and carbon cycle for single plots, which have then a dimension of 100 times 100 meters. We are doing this because our second goal is to implement a data assimilation framework, which will allow us to predict or to provide the best possible prediction of soil water content for the next 14 days for the specific plot with the specific crop on it. So the pilot site is ideal for this testing or this solution because the Selhausen site is part of or is a critical zone observatory, and because of that we have continuous records of meteorological variables, of soil states, soil observations. We have hydrological information, hydrogeological information, and we collected this already 11 years in the past 11 years, and so we have for every 10 minutes we have a measurement of these values, which we can now directly use as input parameters for our models. Yes, there are one big challenge. So we want to simulate every day a new prediction. So we need every day new measurements. This means we have to continuously sample new data, and here it can happen that the system has or stop operation accidentally, and then we have gaps in our records, and this is what we have to avoid. And if we have gaps, which sometimes unfortunately happen, then we have to fill the gaps, and this is getting more complex the longer the time gap will be. So we try to minimize that, of course. So that will be for sure the operation and application of this model. So the idea is that first we test the framework or the idea we have, and if it is working, then we will establish it in operational mode. So this means that farmers could be helped with daily predictions. So it's a kind of a quantitative support for long-term decision-making in agricultural operations. And in parallel, the code and everything we are producing will be open source, so it can be used by agencies or by consultancies to replicate our method on other sites with their own data, and then they can make their own predictions and their own supporting tools.